So, I guess I'm teaching you guys PyGame. So what we're going to try to do today is I'll show you how to make a window in PyGame, draw some stuff on the window, use like your arrow keys to actually move stuff on the window, and then collision with items and like that. So first I'll talk about Python itself. Um, there's this thing called a Python virtual environment, which is, I want this one. So in Python, when you add a package, so like for example PyGame here, you really don't want to install it um, kind of globally. So what you do is you make a virtual environment, which is this here. So if you're on Windows, you just throw in this command, and then you can throw in this command, and it'll activate the virtual environment, and it'll give you this. And then when you install a package, it'll install into this. So like PyGame, for example, is right here. So you don't clutter packages. Because if you do just globally, you can have different Python programs that use different versions of software packages, and they can conflict and all that, and it's just a mess. So just the basics on Python environments. So we'll head right into PyGame now. So when you first start a PyGame game, you actually have to import it and then make sure you have it installed and all that. Oh yeah, and I should also talk about when you're using Python, you have to also make sure, and you're using a virtual environment, you have to make sure you're using the integral and the virtual machine environment and not the global one, because this is the global one, which is Python installed on my PC, which usually where it goes, and then this is the actual virtual environment. But anyways, so I have in my virtual environment PyGame already installed, so it finds it, and then once you start a PyGame, actually, because you have to initial a PyGame here. And then mostly how it works is everything runs in a while loop, and then you keep it true. But okay, first you have to initialize this. Actually, I'll just run it to show you what. So all this code just gives us this. So first we defined a height and width, and then this here will make a screen. So the screen our screen width is 600 this way, and then our height's this way. I guess I'll show you this too. So I guess I should tell you this. Position of windows, they start on the top left, not like you'd think the bottom left, because most things like that. Like if you took any math, you should think of that. But it actually starts on the top left. And then here's your X, and your Y, or width and height, depends on what you were doing. So when we have a window of 600 and then a Y of 800. So that's your width and height. And it's based off this top corner here. So, and then if you want to sit the image, so see how I have a block for this image here? I'm using a resource, which is here, which is the block here. That's how you change the icon and the top left. And then same with the top, text here. I have it set as block. You can change it using by set caption and same with set icon. I guess I should talk more about set mode. Set mode, you usually just go, it's a tuplet, that's the size of tuplet, which is height, width and height. And then there's different flags and everything, but you don't really deal with most of this. You really don't need to. Some of the flags, for example, you can put is full screen. So when someone runs it, it'll set full screen. And then if you really want to learn more about it, I threw in here in the links with documentation. So if you want to learn about virtual environments, PyGame, keyboard inputs for PyGame, collision, and then a bunch of examples I gave. But yeah, this just gives us the documentation, and you can look through it all if you want to look more. But and then so this sets up a window. this sets up an icon and caption, which you really don't need. It's just if you want to be more fancy. And then this is all bread and butter, I guess. It's all while loop because everything runs in this. So we have to make sure it runs true, and then it's gonna loop and no loop and no loop. So it's always running until we tell it to stop, which is set by using PyGame event.get. The only way to close this is using the X button to actually close the game, close the window, because it's gonna keep on looping until it sees an event that it's equal to quit or turn false, and then it like the while loop and then hit quit. And then fill like to fill the back screen, for example, to this pink, we can set it to use screen.fill. And this is all based off of RGB. So I can change this here to be, I think it's, make this white, I think. Yeah, which is ugly. Yeah, so it's just RGB. It's a tablet too. So SB, as you because the field takes a tablet, not it's a triplet, I guess, not tablet, because tablet's two, I think. But it just takes 3 points, which is your red, your green, and then your blue. So you can just throw in RGB value to fill in your background, which is what you can just declare as a variable too here if you really want to. So I can just like throw in color here, which it may make it fuss out because yeah, I can move it up here, which is just white. Which we get back to that. But and then for example, this rectangle here, this is based off the PyGame draw.rect function here. It takes a left. Well, first it takes your screen and then color, and then this rect here is talking about this rect here, which is based off of rectangles, which is a good example here. So dot rect is based off your top left corner here. So the first two here, it tells you your top left corner of your triangle. So it's our X and then our Y value. So it's 150 for X and then our Y value is 100. So where those two intersect is where our corner piece is going to be. And then for example here, this 20 and 30 is the pixels of the rectangle. So it's 20 by 30 this way. So it tells you how big this tells you where it's going to locate the rectangle, and this is how big the rectangle is going to be. So draw, because we have to tell it what window it's going to draw on, which is up here, which we set. And then the color, what the rectangle is going to be colored, which is we set here. And then we draw a rectangle, which is going to be 200 by 190. And then the rectangle is going to be 100 by 100, which we can set this down to 50 to 50. And then our rectangle, it's like this right now, but if we go run it again, it's going to make it smaller. And then if we want to make sure it actually, because each time it goes for the while loop, we have to update our screen. We can either use flip or update. They literally do like the exact same thing. As I commented, it'll update the contents of the entire screen. And then update will do the same thing if no arguments are passed. So if we have no rectangle list, so for example, we made if we made a rectangle like this rect2 and then passed it into the here, it'll only update rect2 and not the whole screen. But we could usually just leave it empty because you want it to update the whole screen anyways. And you should usually only have one of these, don't have two. Or you can have it'll start like flickering and not look good. So you have to make sure you have all this to make sure it actually updates and everything. And then once we're out of the while loop because of we quit, we have to actually close tell PyGame the game's done. So I'll literally just like uh so for like an actual window, this is all you need and to actually get a window going. All that other stuff is just filler really that you can add stuff to because this just initialize. This sets a window, which is this, what size we want. This sets a true value for a while loop. This makes it so we don't exit this window until we hit exit. And then this just updates the window, which we really don't need here because we're not updating anything, but it's good practice to have. And then finally, you quit your program. And then we'll go do something more complicated. For example, deal with collision in that. Nothing too crazy, but here, here I'm just gonna do because you can use .rect or you can actually load images. For example, that image I showed you was the block. This block, I'm calling it to be oh, whoops, wrong one. It's being a one that's moving around. So I'm using an image based off that and not just a rectangle. But so I just made a class real quick. It just gives us the location of the file for this location. It's giving us this here. This gives us the X and Y that we gave it. And then, for example, it's moving on itself. So we gave it X and Y speed, which I declared here. So I made an instance of it anyways. So it's almost the same thing here. This just sets our icon. This sets our icon. This sets our caption, as we were talking about before. Same thing here. Last example. And then this time we're making a rect, which is a white one here because it's spawning 250 and then 100 and then it's 300 by 100. That's why it gets it's this. And then we're calling the image here. We're making the block location that we used to throw in here, but we're calling it in our instance here. It's if you're just using a JPEG and you have no transparent background, you can just use convert. But if you have a transparent background, you should use transfer to alpha, or your transparent background won't be transparent, it'll be white. So it just looks really bad. And then I'll talk about this later. But and then we have to set up a clock because we want our frame rate because we're gonna use the clock to set our frame rate because right now it's 160 at 60. Ugh. So it's going that fast. Not too bad. But if I set up to 120, you see it's moving a lot faster now. Usually you try not because was it how this why it's set to 60 is because this clock ticked out because we made a clock here and then we're calling clock tick. So this while loop will only um loop through 60 times per second because we set to 60. So for example, if we don't have this clock, it'll just try to run the while loop as fast as it can, which will be really bad, especially if you have like a fast machine, it'll run it maybe like 1,000 times a second, and then you'll be like moving so fast you couldn't even tell what's going on. And then that would be also bad because if you have a slow machine, it'll move slower, and then if you have a fast machine, it'll be moving faster. So you usually just put a cap on the frames per second. There is ways to not base the physics off frames per second, like putting a clock on and all that, but it's a lot more work. Like example that was it has the frame rate, like animations and speed tied to the frame rate is Bloodborne, for example. It's locked at 30 frames per second, and if you move it up to 60 frames per second, everything speeds up in the game, which makes it very hard. So I talked about the clock, what it does, and then there's a collision function that I'll show you later. But this here, it's how we're going to get the user input. For example, I'm using the arrow keys to move this white block. So what's doing is we're looking for events in PyGame and then just different event types. So if it sees key down, which we press the key, it'll look for if the key is equal to K escape, it'll close the program. If it's K up, which is my arrow key up, down, left, and right. And then it just changes our block movement, which is based off here, so I can change how fast I want the block to move. For example, like here's like me clicking once. I can change it to say like 60. Mm, I should say that's probably more. There you go. Now it's jumping even more because um because what we're changing is the x and y of this vect here, which we defined in this draw function, but I'll talk about it later. And then same as basic one, where we're looking to see if we hit that exit button, we're checking it here too. And then this is just more collision. I'll talk about later. And then we talked about this before, where we fill the background was filling. That's how we get a black background here. We can change it to a red one. It's gonna be red now. Same thing as before. And then I made my own function called drawing, which just calls it up here. So the block speed. So our block here, which is our class here, has its own functions called x and y, which gets called, and then depends. It adds and adds the speed to them. Yeah, I can do that really if you want. So we're just create adding the. So for example, would I clear that? Oh, it's that. I declared it in here, but so x speed here is just 3 because it's 3 up here, and then we assign it to x speed because of block. So if I really want to, I can make it go faster, so I can go like 10, for example. And then we actually see it's moving a lot faster now. And then same as the y value. We're just changing the y value, y and x value to move the x around the screen. And then PyGame, same thing, like the draw thing. We're just drawing it again. For example, when we draw it here, we're just doing the exact same thing with this rectangle that we made here. This, because we're using an image here, it's a little different because we don't use draw. We have to use blitz, which we call a screen. So this here. And then you call blitz, and then we need the block location. So where it's located. So that's why I called it. I made a block location, which I passed to here. So our block class has a dot location, which I call here, which then has a tuplet to x and y, which I give us the function definition here, which as you can see, blit takes the location and then the x and the y as we gave here. So this will draw, so if you want to draw anything that's not like a rectangle, you have to call blitz and then tell its location and then it's x and y. Because the x and y tells you where you want to draw. For example, it's at 300 right now. I can change it to 100 and 100. And this will change where it spawns. See, it's spawned up in the top left. We can make it be 400 by 400. And then it spawned down here this time. This just moves our x and y value. And then that gives us this. That's our drawing functions. You really don't need it to be in here. It's just like for example, I could literally just throw this like this here. Whoops, that's not what I want to do. I could throw in my while loop like down here. Does the same thing, but it's much easier to have stuff in functions so you don't clutter up your while loop and all that. Because as you'll see with the collision, you'll it's a little messy. So that gives us a drawing. So each time it'll draw this on the screen, and then it draws this too, and then we have to make sure we update our screen to actually have a new picture on the screen. If not, it won't update the screen, and it'll just look like how it initialized. It won't do anything. So I guess I'll talk about collision now. Yeah, I made its own file for it. So collision, how I'm doing it here. So this function here, it'll check to see if it's touching the window. For example, see how this squares bounce off the windows? Well, it's checking to see if the x and y values are like part of the I think I broke the thing, but she checks to see if x and y are part of the like same in the same domain of 600 and 800 here. So yeah, I'm just gonna uncomment these to make it easier for us. So when we run, and then I'll close it when it hits about there. So right here, it's outputting our rect. It tells you where it's at, what size our rectangle's at. And then I guess I'll show you this too. So example, because whenever you make a rectangle, I'll have a top, a left, and a right, and a bottom. So PyGame will calculate this for you. So when you call a rect, you can go rect.left, and it'll give you the leftmost, and then rect.right, where it gives its most right, and then same with top and bottom. So this gives us so it's 10 pixels to 10, and then this would be a 50, and this would be 150 and 155 for the top and bottom, the bottom top. So I guess I should also talk about this. So rectangles, like this rectangle that we made, has dimensions as here, and then as we defined up here. Even when you call it image, for example, this convert here, this also has a rect. Whenever PyGame makes loads an image, it also takes the dimensions of the image. For example, this image is 40 by 40 pixels. So this is why it gives us the 40 by 40 here, because it gives us the rectangle of the image, which you take the location and you just go .rect, and it'll return a rectangle for it. And then I'll just assign the x and y to the rectangles because we defined it up in our class here. So we can call location and then our x and y. And then collision is very complicated. It's not very fun to do. So what we're doing for this moving square that we're doing, this small one that's moving around, what we're doing for it is we're checking to see if the rightmost part of it is greater than the width or the leftmost is less than 0, because we're checking to see where it's at on the screen. And if it's either one, we tell it to multiply the speed, which is here. It's in our class, but we use it here. We multiply it by -1 to flip the sign of the thing, so it's negative. It'll times it by negative to make it a positive, or it's a positive times by negative to make it. Yeah, it's being uploaded to YouTube, and then this code is also I made it available on my GitHub too, if you want to look at it. And then I'll show you a bunch of examples too, if you want to look through it. So this is just collision with the window, as the function says. And then this finds a collision with the other one. So it's with a big one. Let's check to see if it's colliding with the window too. So I can't go past it. Which is mostly doing the exact same thing as here, but we're checking with um, width too, and then we're just changing how many pixels to knock off screen, which, for example, for the window one, for the white block, this one, we'll call it here, and then if it doesn't find, if not true, so because this returns true, if it's not true, you can input commands, and if it's false, uh, if it's true, actually, if it's not true, it'll do this, and if it's true, it'll do this. So if it's so you also have to, because I can't just have it be just 0, because if it's 0, for example, I'll just click that. Because what that numbers do is, because now I'm stuck. So I have to reset the value to be at least greater than 1, because this value here, it moves your square root back. So for example, I go all to the right, so that's 800. Is it 600 or 800? What are we at here? It's 800. So it'll go all the way 800, and then if it just stays at 800, this function will be always true, so you can't enter commands. So you'll be stuck there. That's why the white rectangle was stuck. So you have to minus it by like 2 pixels, because these numbers here, like the 2 is 2 pixels or 4 pixels, depends on what you want to set it as. You have to set it there so it doesn't get stuck in like the for loop, and then you can't control it at all. And then this is just all the different versions. So like this is the top, rightmost, leftmost, bottom, and top. And then this one's not fun. This is when we have interaction between, like, let's see if this one's it's a moving square that we're not controlling. It sees if it's a window, and then we gotta check to see if the two squares hit each other. No, I think it crashed. Yeah. So for example, if we want it to bounce off each other, we have to check that the collision hits each other. So how we can do this is we have to get the two rectangles, because it takes a rect, this collision react. And then we have to check to see if the top value of this one and the bottom value of this one, if they minus each other, they should equal out to be 0. or less, and then can't, because these x and y values can be floats, which we don't want to do. So that's why you take an absolute to make sure it's not a float, and then we also put a collision tolerance, because if two like rectangles hit, if they're fast enough, they'll overlap, which will kind of break. Because here, I'll comment out some stuff. So if we don't do that, it'll just cut right through, but it's not exactly what I wanted. But see how the triangles are overlapping when they move through? If it's fast enough, for example, if the square is moving fast enough, it can phase through and then get like stuck in that rectangle, which we don't want. So that's why we have to put a collision tolerance, because when, I guess I'll just open paint. Probably the easiest way to explain this, how to explain words. For example, we'll make this like, that one's fine. And then, for example, another square hits it. Our overlap clearance that we're talking about is this distance right here. So if we just have it set to 1, and then it overlaps like this, there's probably, say, like 10 pixels here. We can't have it just have 10 pixels, because we would, if we just have it, there's no tolerance, it'll just get stuck in, it'll pass through, and then get stuck in this other rectangle, which is not what we want. So that's why we have to talk about clearance. And then sometimes it kind of does get stuck in it, so we have to make sure our values, like for example, our y speed here is greater than 0 if we're changing the y value for the top and then the bottom, different ones. Yeah, it's really hard to explain collision. You have to kind of read up on it. It's very kind of complicated. And then I think that's all for my example. And then for a lot of resources, like this here is just talk about the back to left, top, and all that. But I gave a lot of references. So, for example, if you need help setting up virtual environments, there's this, the documentation for PyGame here. If you want keyboard inputs, there's a Geeks for Geeks thing, and then how I was using it. I was using like key up and all that. That's part of this here, all these. So if you want, for example, so like my arrow up and down key and all that. And then I think that's it from my example. But if you actually just look in PyGame, for example, PyGame comes with a ton of examples too, which like here's like the list of them if you want to look for them. You can either do what's suggesting here is you import it and then you call it certain main. You can either do that, or for example, we see for here we can run aliens. It'll give us that. And then if you actually want to go look at the code or run actual examples, if you go into your virtual environment, go to PyGame, go to examples, and then here's the alien one, for example, and then this will give you all the code you want to look at. And then there's a ton of examples you can look through. For example, this chimp one is like why. It's just that. And then there's just a bunch of other ones you can look through. And then I also listed more examples if you want to look through. this gives us the PyGame one. This is just a GitHub, which examples. For example, I can open up. And then this is just all the different things you can do PyGame, which is all in this code here. It's all in here. You can go look at the code if you want and learn how they actually did all this. And then same with this one. And then this one's a little different because this guy made his own function for PyGame, which is supposed to make it easier to PyGame, for example. So if you really want to, you can look through his, oh, not that. You can look through his thing, and because he made all these functions, which supposed to be easier to use PyGame, but you can look through it if you want. And then if you really want to be cool, there's this guy who made like a copy of Stardew Valley but in PyGame. So you can go look through all that. I have it opened here. Like menu, overlay. He made all this. It doesn't compile right now because like I don't know why, but it was messing with all the all the images were messing around with it. But you can look at how he actually did everything. So for example, like his while loop is like true. So it's game loop, for example, that's what it's actually called. And then did I cover everything I want to? Yeah, I think so. You guys have any questions you want to know? No questions. Any question, guys? Question, guys. I think I'm done then, if you guys don't have any questions. Yeah, if you have any questions, I guess just message me if you have any questions about PyGame. It's not too hard of a thing, especially like, it's literally just, as I was saying before, it's literally just, you just need that much. That much code to make a window. Which is not a lot compared to like C++ and all that. That shit sucks. But yeah. Um, do I have anything else? I guess I could show you how to make a virtual environment real quick, I guess. I'll delete this one real quick. And then I also give you a list in here, which is also in, if you go just Python for VS Code, it gives you all this anyways. It tells you about selecting, what is it, interpreters and everything. But if you want, what is it? Yeah, it's just talking about install packages. So this will tell you how to make a virtual environment. Like this command creates it, and then this one activates it. You may have to throw this one here because Windows doesn't like it when you run scripts. So you may have to throw that one in, and then make sure you select the right interpreter, and then you can install packages. So, for example, I can throw this command in. I'll make a new terminal. Throw this command in, and I'll make a virtual environment up here. And then I already have it set, so I don't need the other one. I can just throw this in here, and then it'll be my virtual environment. But as you can see, if we go in libraries, we don't have PyGame in here. So usually you throw this one in, or this here, but I'm using kind of like a newer version of Python, which breaks if you do. So I have to use this PRE, previous version, mostly it's what's called, to actually install PyGame, which you just go like that, and then we'll have PyGame, and then you can call it in our functions, and it will actually have it. And I think I'm done. Any questions? I'll take the silence as no.
Thank you.